Hi everyone, I hope you are doing well. In this video, I'm gonna connect logistic regression, a famous algorithm in machine learning for regression and classification, to the LMS algorithm, a well-known algorithm in signal processing. We will show that logistic regression is equivalent to LMS algorithm. We only need to add sigmoid function to the LMS algorithm. Before I start to discuss about this topic, I will say a main point. Actually, I need this point for our discussion. We have a fine estimator which is defined by Z equals to W transpose X plus B. We call this a fine estimator. Here is bias and here it's a weight vector. I can behave with this bias like a weight vector. We can write W transpose X plus B is a scalar, B transpose 1. It means B is a weight and the input data is fixed and constant and it is 1. So I can write this relation as B W transpose multiplied by 1x. Now I can consider this vector as a new vector, new W, and this is our new data. That means I can use this relation without loss of generality. W equals to W transpose X. In any derivation, in any equation for W, if you want to have that equation for B, you only need substitute X with 1. So I don't want to discuss about the equation regarding B. I only talk about W. This is the first point that I had to discuss and explain it. Now let's continue. First of all, I would like to talk about least mean square LMS adaptive algorithm. In framework of adaptive algorithm, we have observation, for example X. We have a filter, FIR filter, for example with the weight vector W, and the output is W transpose X. We have a desired signal, for example we call it D, and we want to estimate W in a way that W transpose X must be similar to D. We call it D is desired signal. And this is the estimate of the linear estimation of desired signal. We will have error equals to D minus output of filter, we name it Y, D minus Y, and then error fed to LMS algorithm or any adaptive algorithm to adjust W. This process will continue until we converge to a fixed W. And how W what is up to the rule for W? We use gradient descent. Gradient descent method. How it works? W new, for example, Wi plus 1 equals to Wi minus mu gradient of loss function in Wi. This is the gradient descent method. In LMS algorithm, we consider J cost function or our loss function equals to 1 over 2 E squared. And if we take gradient with respect to W, round G, round W, we use chain rule, round J by round E multiply round E over round W. What is the derivative with respect to E? It simply is E. What is this derivative? We have E equals to D minus W transpose X. So round E with respect to W is X. We have X, here is a minus X. We have a negative sign here. So we have minus EX. If I put gradient in the gradient descent method, we will have Wi plus 1 equals to W plus mu error D minus Y multiplies by X. This is how LMS algorithm works. Let's continue and see how logistic regression works. I want to use logistic regression as a classifier. And I have, for example, binary classification. If I have two classes, I can have several classes, and we can call it multiple classification. So we have here, I talk about binary classification. We have features. Here, X is features. In the context of machine learning, we call X feature. And then we have weight, which is W. We have bias, B. And we have activation function, which is here sigmoid function, sigma. And the output is prediction or predicted value. And data in classification has a target and label. So Y is target or label for our data. Each feature belongs to a specific class. So we have here target, some labels that shows this data or this feature belongs to which classes. This is the predicted value and this is the target, and here I want these to be the same. And I need a cost function or a loss function. And cost function here is the cross entropy. They use cross entropy as a cost function for solving this problem, which is defined by minus y log p plus 1 minus y log 1 minus p. This is our cost function, which is cross entropy. An activation function, we call it sigma activation function. Here is sigmoid, which is defined by sigma z equals to 1 over 1 plus e minus z. Okay, so let's repeat what is going here. We have features, data, we have weight and bias. If we set the initial set for W and B, we compute Z equals to W transpose X plus B, and then Z fed to the sigmoid function, and sigmoid function actually produce a probability that by comparing the probability with a threshold, I can understand our feature belongs to which class. Now let's find how W is up-to-dated. Again, it is based on the gradient descent. Let's find the derivative of J with respect to W. Again, the gradient descent tells us Wi plus 1 equals to Wi minus mu gradient J in Wi. Gradient J or derivative J with respect to W. Again, I need to use chain rule, which is round J, round P, round P, round Z, round Z, round W. And let's continue and finding every derivative. I will start with this. I can take derivative of cross entropy. Here we have log p, the derivative is 1 over p, and here log 1 minus p, the derivative is minus 1 over 1 minus p. And let's substitute. We have minus, we have y over p minus 1 minus y over 1 minus p. And I can have p multiplies 1 minus p, and here we can put minus inside. We can have minus y plus this term, and then we have minus y multiplies 1 minus p plus p 1 minus y equals to minus y plus py plus p minus py p 1 minus p. So we have p 1 minus p and p minus y. This is the first derivative. Let's continue and find round p over round z. Actually, it is derivative of sigmoid function. P equals to 1 over 1 plus e minus z, and I'm gonna compute derivative of p with respect to z. We have the derivative of this term minus e minus z and 1 plus e minus z squared minus 1 plus e minus z. I can add plus 1 and minus 1 to this term. We have 1 plus e minus z minus 1. And we have minus 1 over 1 plus e minus z. And here this term minus 1. When this term is simplified, it is plus 1 over 1 plus e minus z. And equals to, here it's p squared minus p, which is p multiplies by 1 minus p. And what is the last term? The last term is derivative round z over round w. Round z over round w. Z equals to w transpose x or w transpose x plus b. Doesn't matter. Equals to x. I have all derivatives now, and I can substitute. Let's continue. The first one, p minus y over p multiplied by y minus p. The second one, the derivative of sigmoid, p 1 minus p. The last one is x. We can remove this term from this, and finally we have What happens? It's amazing. Can you believe it? It's like LMS algorithm. I only here have P. P is after linear model. I have to use sigmoid. So I can sketch this block diagram for logistic regression. We have X, weight, W, after that sigmoid. This is linear model, and then activation function sigmoid. In here we have Z. Here is sigmoid function 1 minus Z. Here this P, and then we compute error. Error is target minus predicted value, and then LMS algorithm to up-to-date weight. As you see, the main point and the main result of this video here is logistic regression. This is the logistic regression, but it is LMS algorithm. I only add sigmoid function at the output of the filter. I only add a subsystem to the LMS algorithm to have logistic regression. I hope you enjoy this video. Thank you for watching, and please subscribe and support my channel.